Hello, this is Leanrevit with Sean Fruin. This is a continuation on parametric design. So in the last video we looked at how we could start placing equipment kind of strategically, at least with places, and then linking all those pieces of equipment together. So we're going to kind of further see how we can eliminate non-value tasks in this one while also showing how we can make some controlled rules to set elements in a desired location. We're going to of course use Dynamo. We're going to be able to filter some of the spaces, place elements based on rules that we make, and decisions from the Revit geometry itself. So we get algorithms, we get to do things more quickly, more accurately, and more controlled. So when we left off last video, this is kind of what it looked like, kind of ugly. One diffuser kind of in the middle. Just still having to move a lot of stuff around, not really taking in any consideration about how many diffusers should be in the room or anything. So we're going to go about changing that. So I thought about how I was going to explain this, and I know if I just showed you the script, I couldn't. So I'm going to try to I kind of made a flow diagram, if you will. So first, we're going to make points in the room. So this is put our supply diffusers. So then after that, we're going to move those points, shift them over about half of the distance that we put them. This is kind of ideal for placing diffusers. You could even go as far as using the manufacturing data. So then we're going to look at, are these spaces inside the room? If not, we're going to get rid of them. So this takes care of, L-shaped spaces, just weird shaped spaces where you did this and the math didn't get in. So now for the return diffusers, we're going to go and find all the doors for each space. From there, we'll find the wall that hosts that door, and we'll get a vector from there. So again, this is all about vectors, points, 3D calculus. So from there, we'll actually do the cross product with the z vector and get these two normals from the wall. And then we'll move that point from the center of the room outwards, and now we have points all throughout the model looking like this. So now we do the same thing. Are these spaces in the room? Yes or no? If they're not in the room, then we get rid of them. If they're in the room, we have them. Another thing we're doing is we can count based on CFM how many diffusers we'll need. So now for the thermostats. So again, we'll do the same thing, find one of the doors in the room. Now we're going to find the two endpoints for that wall that's hosted on. Find the one that's longer and move it that way. Now we're avoiding kind of putting it in that corner, usually the long way where it's open. So we'll go down that way a little bit. And then again, we'll get the normals to the wall. And now I'll ask, okay, which one's closer to the center of the room? And that's how we'll decide which side of the wall to put it on. So I hope this helps explain. I know we'll get into the script here in a little bit, but this is what the end product will look like. And that's kind of the rules on how we got there. Also, just like we found these door points, those could be windows to help us find something. That could be, toilets in a room to put the diffuser right over that. Maybe equipment, whatever. So let's hop into this Revit model. As you can see, we have no diffusers in here yet, just like last time. Pretty clean slate. And we'll hop right into Dynamo. So let me open up the place diffuser script. So if you remember from last time, it looks pretty similar. All the stuff in the middle, though, is what's been added, and that's all of our rules that we're going to use. So let me get rid of this guy right here. We also added this linked architecture linked models because we're going to, again, mind the linked model for things like doors. And this could be windows, equipment, whatever. We're still going to filter out the spaces by system, supply, exhaust, return. So this is how we're going to filter out the doors for different rules. So you could do any kind of filter you want. Here we're doing less than 100 feet, corridors, stairs, and all the rest of them. So if you look at here, we're getting the bounding box and the max and min points, and that's how we're going to make our grid. You see the gap right there. So again, bounding box, max, mid, and there's our diffuser gap. and then that offset is half that. So that's kind of a fun way if you ever want to get into making grids. You can have them really dynamic. So here we're going to get rid of all the failed points. So let's say we made a grid and it was small. It was a 7 by 7 room. We did that offset 8 by 8. We're going to get rid of all those rooms and then pull those spaces just so we put a diffuser in the middle. So here's where we're actually going to make our grid. So it's cross-lacing the X and Y points that we got from that max and min. And then we're going to repeat that Z for as many points as we had. So we had to do the Z separate because if we were to lace it with the X and the Y, then we'd get like a cube of spaces rather than just, 2D of spaces. So here's where we're going to ask, was a space in the room? So if true, then we're going to get that item. If false, we're going to get rid of it. And that's how we did the grids. So now let's look at returns with the doors. So again, architecture model. Get the right spaces, get the geometry, get the bounding box. Right down here, we'll find the midpoint of the door bounding box. And then we're getting that vector of the wall, the hosted wall, and then crossing it with the Z. So now that we have that vector to move those 2 points, so we're going to add and subtract. So now we have those points moved. That math ceiling is to see how many diffusers we need. So now we're asking, are these points in that bounding box? And if true, then okay, give me the points. And then that take is how many door points should I take, and that's referring back to the amount of diffusers. So now we're going to clean this all up. Again, this is just kind of our extra little pieces, rooms that failed for some reason, just to make sure we all get them in there. When they fail, I just put them in the middle. So I'm going to freeze these real quick and run the script. Like I said, this has kind of been maxing out my computer. And I found if I freeze it, do this step, and then place it. So there's all geometry popping in that just did. So now we'll unfree these and run it. So let's go over here. See if I can get rid of this so we can watch the magic happen over in Revit. Pay attention to that top left room, the one that I did the explanation earlier to. So there's all our diffusers, no CFM yet. Pull this back up. And as you can see, just like the top room said, and all these are following those same type of rules. I don't know why they're not showing up here. I think it's a view range issue, so let me fix that real quick. Alright, there we go. That looks better. So you can see everything followed those rules, exactly where we expected it. The placement is beautiful. Those are all 16 feet across. Again, you could use your manufacturing data to even derive that 16, so it's not 16 for every one. So now let's go ahead and place the VAV boxes and the thermostats. So no air terminal boxes in here. Let's pull up this mechanical equipment schedule. I'm going to turn off the other equipment so we'll be able to see with this schedule that we have all the thermostats for all the VAV boxes. So again, eliminating any risk of someone forgetting to put a thermostat in. I've seen it missed many times. So here we go. So same thing. So vector points, and here's we're doing the distance thing, seeing which one's greater. The one that's greater, we're getting that point. So now we make a vector from those 2 points. We scale it to be about 3 feet. And then we move it down that vector. So here's the normal thing again with the cross product. Again, cross product gives you that normal to the wall with Z. And we will pull the one again, this time that's shortest. And so let's give this a run. So there we go. We see a V box in this room. We see it in our schedule. Let me change this so I can show you that we got as many VAV boxes as we do. So we're filtering by the equipment ID, and you can see VAVT, VAVT. So we got them all in there, all with appropriate labeling. Let me annotate all this stuff real quick. Okay, so there's our VAV boxes. There's a thermostat, so something happened there. As you can see, those two are in the right spot. So, you know, even if it's not 100%, it's still in there. Of course, we're after that pursuit for perfection. Like that one looks right. That one's a little off. So something's a little funky going on there, but we'll fix that. Again, we know they're in there, and it doesn't take that much energy to move it in the appropriate spot because it is close. A little disappointing though. So okay, let's wrap this up with filling in our data into all this. So again, we're going to open up our trusty data distributor script. Same script I used last time, just this time, and I kind of showed this last time, this time we have main diffusers in the room, and it will divide that CFM evenly across those diffusers. So here we go, let's check this stuff out. Let's check our VAV totals. There they are with our Excel file. Those look correct. Let me resort this so we can see the totals for supply, return, and exhaust. You can see we're filling a lot of data in here, which gives us something that we can really sort, and you can really see we're starting to make a good database. And looks like all these numbers are equaling up perfectly. So there you have it. As you can see, we've very powerful stuff. Really exciting stuff to me. We just took tons and tons and tons of inputs and streamlined it. Our model can now adapt, change to anything that we want to throw at it. And we're already off at stuff being pretty strategically placed. The next one, we will get into building systems. I think that's one of the most important aspects of having a good Revit model. And then with all that, we'll be able to start actually getting some engineering out of it, like pressure drop, and see how we can turn this big database into a dashboard. So thanks, guys. See you then. And please like, share, and let me know any topics you guys are all interested in. Talk to you next time.